Hello students. Now today we will start with a new experiment, that is experiment number 7, to design and configure the simulation for dynamic routing based OSPF protocol, right? So this OSPF is nothing but the open shortest path first, right? So this is nothing but one of the dynamic routing protocol, right? And we need to see how to configure this particular OSPF routing protocol in the Cisco packet tracer, right? And how to create some simulation for that, and how to check the features and the configuration of this particular OSPF protocol, right? So if you go in on the network design lab course page, right, so you will find out here the experiment number 7 for the configuration of this particular OSPF protocol, right? So we will first of all see the prerequisite for this particular enterprise the network design lab, this particular experiment, right? So the knowledge of the basic concepts of the networking commands will be required for it, right? Because you wanted to you need to configure this particular OSPF routing protocol in the command line interface, right, by using some of the commands, right? And you need to also configure this particular protocol on the command line interface itself, right? So that you must know that how to configure the routing protocol, right? How to configure the router with the some routing protocol also, right? And also you must know the different you must have the exposure to this particular Cisco packet tracer tool, right? So how these components can be drag and drop, how it can be used, how the wireless media can be used to connect in between all the internet networking devices, right? And for that particular OSPF protocol. So these are the some prerequisite for this particular experiment is concerned, right? Then we will see what is the problem statement for that particular experiment if you concerned. Then you already understood now what you mean by the static routing, what you mean by the dynamic routing, right? So the dynamic routing protocol is overcome the whatever the disadvantage of that particular static routing protocol, right? So if you see in the static routing protocol, right, so the manually the administrator needs to manually update all the kind of the routing information to that router to the routing table, right, for that particular router, right? But if you see in the dynamic routing protocol, right, so here all the details of the routing information will automatically dynamically it can be updated in that particular routing table of that particular router, right? So it is advantage for this particular protocol if you see, right? So in the static if you say the static routing protocol, that's why we are going to use for a small network, right? Because if it is easy to remember all the network IP addresses and all that thing, right? Because it is not manageable, or it can't be you can do to remember all the kind of the things if you are using some of the large network, right? So in that's why this particular dynamic routing protocol can be used in if the size of the network is large, right? So that it will be automatically update the routing information in that particular routing table, right? So we have already discussed among some dynamic routing protocols, right? So for example the RIP we have discussed EIGRP in our last experiment, right? So today we will have some hands-on on that particular OSPF, that is open shortest path first routing protocol, right? And in this protocol we are going to configure our routers, and we are going to check for the connectivity in between the various internet networking devices with the help of OSPF, how it is going to be communicate with each other, right? So this is we are going to do in this particular today's experiment, right? So I have purposefully kept the same logical topology, right, which we are used for configuring all other dynamic routing protocols. For example, if you see in RIP routing protocol also we are having the same logical topology, right? And for the EIGRP also we are having the same logical topology, right? So with the help of the same logical topology, we are continuing for our OSPF protocol also, right? And why I'm doing this, because if you see, by keeping the logical topology same for all the routing protocol, right, so it will be easier to you for identifying the differences in between the protocols, right, to identifying how the protocol can be configured and how it can be used in the various size of the networks, right? So that's why I have kept the same topology, right? So identifying you for the differences in between these different dynamic routing protocols, if you considered, right? So this we need to do. We need that now we will move towards the lab manual of this particular experiment, right? And then we will do some hands-on with respect to this particular OSPF dynamic routing protocol, right? So let's go with lab manual for this particular experiment. Okay. Okay, so here if you see in this particular experiment, right, so for experiment number 7 for dynamic routing protocol for our OSPF, right, that is nothing but our open shortest path first routing protocol, right? So here if you see, it is also a type of your interior gateway routing protocol, right, for the internet, right? And it having some of we can call it distribute some IP routing information, right, throughout the single autonomous system that we can call it as an AS in an IP network, right? So if you see this particular OSPF, that is open shortest path first protocol, is a link state routing protocol, right? That means it will be the routers can be exchanged the topology information with their nearest neighbors, right? So whoever or whatever the neighbors of that particular routers having, right, so all the kind of the information within that particular autonomous system, right, it will be they will be shared the all the kind of the topology information with each other, right? And this particular topology information is flooded throughout the their autonomous system, right? So that every router within that particular autonomous system can have this particular complete picture of the topology of that particular autonomous system itself, right? And if the picture is there with them, right, then it will be easy to them to calculate the end-to-end path in between that particular autonomous system, if you consider, right? And this particular open shortest path first will be uses some Badgujar's algorithm in this particular link state routing protocol, right? So it will be useful for finding out the minimum distance in between that particular hop to hop, right? So it will be very easy for OSPF to calculate the best path over this particular thing, right? So the main advantage of this particular link state routing protocol, like for example the OSPF, if you consider, right, it having the complete knowledge of this particular topology, right, within that particular autonomous system, right? And it can also allows routers to calculate the routes which satisfy, for example, this particular criteria, right? And if you are talking about the features of this particular OSPF, right, so if you see in this particular manual also, right, the first feature is the protocol. It can be recalculate the routes when the network topology can be changed, right? So whenever the network topology can be changed, whenever the any scale up or any scale down will be there with respect to that particular network, right, then this OSPF protocol can be recalculates all the routes, right, with the help of some Badgujar's algorithm, right? And it will be also minimizes the routing protocol traffic that whatever it may be generates, right? This is the feature, one of the feature of this particular OSPF, right? And also it will be support for the multiple path which are having some equal cost, right? For example, if we are if this particular OSPF is calculating the path or the cost for the equal link, right, then if any path, any one or two path will be the similar which having giving you the equal cost, right, then then this particular OSPF protocol can support all these kind of the multiple path, right? And also if you see, it will provide you the multi-level hierarchy, right, which we can call it as a two level for this particular OSPF, right? And we can also call it an area routing, right? Because we are using some kind of the area keyword in this particular configuration also, right? So we can call it an area routing, right? So that whatever the information about this particular topology, right, within that particular defined area of that particular autonomous system, what we can call, right, it will be hidden from that particular router which will situated outside this area, right. And depending upon the whether it will be inside the area or the outside the area, we are defining some autonomous system over there. We are assigning some random values to that particular area within some range, right. And that can be we can use while the configuration of this particular OSPF, right. We will see that in and hands-on also, right. Then this can be enable the additional level of routing protection and reduction in the routing protocol traffic, right. So because of this particular area whatever we are using for internal traffic, or for example the inside the area or outside the area, or whatever the distinguish in between the inside the network router or outside the network router, right. So it will be help to provide the routing protection, or it will be also reducing in the routing protocol traffic, right. So this is also one of the great feature for this particular OSPF is concerned, right. And the last one is all protocol will be exchanged can be authenticated, so that only trusted routers can be joined in the routing exchange for the autonomous system, right. So now whatever the exchanges in between means that whatever the traffic is can be transferred within that particular autonomous system, right. So all the routers which we are taking part into that particular communication, right, these are the trusted routers, right, that are within that particular autonomous system, right. So that it will be provide you the authentication and some kind of the security also there for this particular OSPF if you're concerned, right. So these are the something related with the OSPF protocol, right. Some of the theory and some of the technology, some of the features with respect to that, right. So this particular configuration, if you the topology if you consider, right, so we already discussed this for our last two experiment, right. So while RIP or dynamic routing protocol, while EIGRP dynamic routing protocol, we have used the same topology, right, and the same topology we are going to use now for our open shortest path first dynamic routing protocol as well, right. So here if you see, again I have used the three routers over here, then the two switches and the four systems over here, PCs over here, we can call it as an end device over here, right. So which are connected to this particular router via this particular switch, right. So whatever the IP addresses for this particular PCs you are going to see here, right. So for these all PCs, for example these first two PCs, the default gateway will be the router's IP address, and for this PC the default gateway will be nothing but this router's IP address, right. And this first router and the second router, if you see here, there is an the link is nothing but the serial communication will be there in between these particular two routers, right. And this is nothing but the third router which we are connected to here, the second router, right. So these are nothing but the topology we are going to create for our OSPF protocol demonstration, right. And if you see, I have created here one table, and if you see here for the each inter-networking devices, I have given here the interface on which it has connected and whatever the IP address which I have given here, right. So that you need to find out in this particular table, right. So from table also you can design this particular topology, or from the topology also you can create this particular table, right. So vice versa can be, you can create it, right. And you can also compare this particular, you can also compare or you can also matches this with this particular logical topology, right. For example, if you see router 1 has two interfaces, whether router 1 has two interfaces or not, right. If it having, then what are the interface name is there, right. So FS0/1 and S1/0, so FS0/1 and SS0/1, right. And what is the IP address of that, right, 10.series and 192 does 10.series and 192 right. Likewise you need to compare each and everything, right, and you need to draw this particular logical topology over there, right. And then if you see the syntax for this particular OSPF protocol, right. So whenever you are configuring the router for your OSPF protocol, right, so you already know that the router under into bracket the config commands will be there, right? And in front of that you need to configure the router as a router space protocol name, right? So for the RIP we are giving here the router space RIP only, right? And for EIGRP we are giving router space EIGRP space some random number that we can call it as an autonomous system name, right? But here you need to provide process ID, or you can provide it here that area that randomly any kind of the number, right? So and which will be in the between your 1 to 65535 only, right? So for router OS for the you need to, for example, you need to configure this particular router as OSPF. Then the syntax will be router space OSPF space the ID number that, and this process ID is in between your 1 to the 65535, right? And the next one, if you wanted to define a network under define the network into this particular configuration of router, right? Then how do you do that? The network space the network address, that is the IP address of that particular network, that will be always your the starting IP addresses, right? And space the wildcard mask over here, and also you need to mention the area, right? So as I already mentioned you, the area is nothing but so whether that particular network or that particular routers which we are using, right, that is inside that particular autonomous system or not, right? So depending upon that this particular area is defined, right? And if you are going to configure any kind of the large network, right, then these particular areas will be multiple areas you can be defined, multiple OSPF routing protocols you can be defined, right? And depending upon area you can measure that whether that particular OSPF or whether that particular router is in between which autonomous system, right? That you can also be defined, right? So for this particular area is also in between this particular range, right? So 0 to that is big number, right? So now here what do you mean by this particular wildcard mask, right? So this wildcard mask we have already seen in our I think for firewall experiment, right? So because in that also you need to provide wildcard mask for your IP addresses, right? So whatever the IP addresses you are giving, right, so whatever the net mask will be there, right? So that net mask you need to write it in reverse direction, right? For and it can be, you can write this wildcard mask, right? For example, your net mask is, for example, the 255.0.0.0, right? Then what you need to do is you need to opposite of that what it is, right? So 255 in opposite of 255 0, for example, right? Then 0 what is the opposite of 0? Then 255, right? Then the 0.255.255.255, right? So in that way you need to define it, but that particular wildcard mask, right? And whatever the area which I have discussed with you, right? So that area you can represent in two way, right? For example, the decimal format also you can denote that either way, or you can use the IP address format also, right? For example, if you wanted to define a decimal way, then you can write the area number as a 20, right? But if you wanted to define it as IP way, then you need to put it as 0.0.0.20, right, in terms of the IP address format, right? So there are two ways to define this particular area, right? This wildcard mask is nothing but the opposite of whatever your net mask is, right? And the network address you know already you wanted to define in this particular OSPF routing protocol, right? So now we will configure this particular our routers, whatever we have shown in this particular logical topology, right? That we need to configure with respect to our OSPF routing protocol, right? So we need to define here the wildcard mask also, and we need to define here area also, right? So if you see here in this particular router number 1, right? So we have the initial IP address for the two interfaces or the two networks in this particular first router, that is 10.0.0.0 and 192.168.1.0, right? And if you see, we need to configure this so that if you see router space OSPF space 200. Now here this 200 is nothing but the process ID for this particular OSPF, right, as we are discussed, right. So if you see here, what is the syntax? Router space OSPF says process ID in between must be 1265535, right. So we are just randomly assigning here to 200, right. So likewise you need to define for each router, right. So here also if you see for router 2 it will be 200, and for the router 3 also it will be a 200, right. So then next one is for router 1 we have two interfaces. So both interfaces starting IP address you need to configure here, right. And also the space, what you need to do is you need to provide its wildcard mask, right. The first of all, if you see, the first IP is nothing but of the class A, right. That means it is having the net mask 255.0.0.0, right. But we need to provide the wildcard mask for this, right, and it will be opposite of your net mask. So it will be your 0.255.255.255, right. And the area you need to define according to the syntax of this particular OSPF routing protocol, right. So area I am defining here, for example, the 0, right. Then the second, for the second interface also, if you see the second initial address of that particular second interface, it is 192.168.1.0, and this is nothing but the IP of class C, right. So that the you know already the class C net mask is 255.255.255.0, and we need to use the wildcard mask. So opposite of that, that is nothing but 0.0.0.255, right. And the area also I have now I have put it here in terms of the IP address, right. So that's why this 0 becomes 0.0.0.0, right. So I am just giving here the example, right. So how this particular area can be defined, right. So here in the first case I have defined this particular 0 in the decimal format, and for the second one I have put it this particular 0 in the your IP address format, right, if you see. Right, now this is all about your router 1, right. And if you see router 1's network starting addresses, right, so you will just go to this particular logical topology, and if you see the IP addresses whatever there are on that particular interfaces, right, so you need to just mention the starting IP address of these particular interfaces, right. And for router 2 we have the 3 interfaces, right. Then we need to provide 3 starting IP address, right. Then if you see here the network again 20, that is class A, so I have put it here the opposite of net mask, that is 0.255, and again I am putting here the area 0, right. But for network 3, if you see here I have put it here 155, 150, 150, 150, 150, 0, and the net mask is also wildcard mask also I have given. But area, if you see, I have defined here the 1, right. Why 1 now? If you see here for this particular network, right, so it is in one common autonomous system, this particular thing, right. But if you see this particular network, right, from this router to this third router, right, it will be in a different autonomous system, right. So that's why I have provided here a different area, right, that is area number 1, right. So if you see here for router first I have put it area as a 0. For the router 2 first 2 path I have first 2 network I have put it area as a 0, and for the third one I have put it area as a 1, right. And if you see for the router 3 also I have put it the area as a 1, right, because it is an outside your network or outside your routing protocol range, right. So that's why I have put it here the area number 1, right. So this is how this particular OSPF can be different with respect to the RIP and EIG RIP, right. So here you need to mention the process ID, also you need to mention here the wildcard mask also, and here you need to mention the area also while the configuration of this particular OSPF, right. Then after configuration, if you check with the show IP on that particular router, right, then you will show space IP space root on that particular router, right. So you will get all these codes, right. So this particular O is nothing but for the OSPF. If you see O for OSPF code, right. So whatever the IP addresses you will get it here, right. So you have the 3 routers, right. So for the 3 you will getting here the 0 that is nothing but your OSPF you have configured, OSPF you have configured, and OSPF you have configured, right. So these are nothing but your router 1, router 2 and router 3, right? And also you can be see the what is the neighbor for neighbor routers, right? So with the help of this particular command, show space IP space OSPF neighbor, by using that you will find out what is the interface, and for which interface which IP address will be using, which is nothing but the neighbor of that particular OSPF, right? Then also you will see the border router, right? Which one is the your border router is there, which we can call it as ABR, right? So show space IP space OSPF border router. So it will be giving you the process ID first, right? And it will be giving you again the border routers as also, right? And again one method that OSPF having, that is the OSPF routing database, right? So you can also see show space IP space OSPF space databases, right? So it will be gives you area wise whatever the link ID is there, whatever the routers will be there, right? And checksum and all that things with respect to that particular IP addresses, right? So this is nothing but the database of that particular OSPF, right? And you are also going to getting ping from every internet devices in that particular OSPF, right? If you go with that, right? So this is with respect to all the information with respect to OSPF routing protocol, right? So we have seen what you mean by OSPF, their different features, their logical topology, their IP address configuration, and how the OSPF configuration can be different than the RIP and the EIGRP, and how it can be configured, right? There are some new terms we have learned, that is autonomous system, then the process ID, then wildcard mask, right? And the area, right? So all these things you need to keep in mind with respect to OSPF routing protocol if you concerned, right? And there are also some of the techniques by which you can check the database, you can check the routes and all that things, right? So this is all about your experiment number 7, right? So we will do some hands-on with respect to this particular OSPF part, right? So I will just open that the Cisco packet tracer, and I will show you the configuration part over there, right? So I will just shift it to Cisco packet tracer. Okay. Okay, so if you see this particular OSPF protocol configuration, right, the same topology we are going to use it here, right? So I will just show you the configuration first for each and every internet fucking devices, right? So just starting from this particular PCs, I am going to show you the whatever the configuration I have given to this particular thing, right? So just go to the IP configuration of each of the PCs, right? So if you see here, I am giving the 10.0.0.2 as a IP address, and the routing protocol, the router's IP is nothing but the default gateway for all these PCs, right? So for first two PCs, the default gateway must be your 10.0.0.1, which I have given already, right? So I will just show you that particular thing. So for your second PC also, I am having the same default gateway as the router's IP, that is 10.0.0.1, right? And the IP is 10.0.0.3, right? And the same thing is for the second network, second router's network, that will be your 20.0.0.2, and the default gateway for this particular two PCs will be nothing but the router's IP, that is 20.0.0.1. If you see here, I have given already this particular default gateway over here, right? And for the last PC also the same thing. I just show you. Okay, so if you see 20.0.0.3 and the default gateway also 20.0.0.1 for the PC7 also, right? Now we will move towards this particular router's configuration part, right? So here if you see, going to config tab, and if you see the fast Ethernet port, I have IP as a 10.0.0.1, right? And for this particular serial communication we have 1.1, right? So if you see, and we have again also the clock rate, right? So you can set it from here itself, right? And here if you see, there will be no any routing section, there will be no any OSPF, right? So for that OSPF you need to go to this particular CLI part, right? And after that you need to add over here all this kind of the configuration of this particular router as OSPF, right? So all this autonomous system, wildcard mask, area, and all that things you need to use it on this particular CLI, whatever we have discussed in our lab manual, right? Then on this particular router number 2, right, on configuration, if you see the again the IP address, so here there are three interfaces, right? So for this 0/0 you have and 150.150.150.1, and for the serial communication you have 192.162.1.2, and for that particular 0/1 you having this particular 20.0.0.1 as an IP address for this particular system, right? So this is for router 2, and for router 3 we have yes, this for router 3 we have 150.150.152 as an my IP address, right? So this is we have done the configuration for all the internet networking devices, whatever we have discussed in our lab manual itself, right? And after configuration in CLI, each router with the with that particular OSPF protocol, right, we are going to ping now from each of the PCs over here, right? So so first of all it will be get failed, but it will be get successful in the next half, right? So if you check, all the connection will be successful, right? Okay, from the second also we will do some reverse thing, right? So it will be successful, right? So it will be successful, right? So in this way we have successfully configured this particular OSPF protocol on this Cisco packet tracer, right? So we have seen RIP as a dynamic routing protocol, we have seen EIGRP as a dynamic routing protocol, and also we have seen this OFPF as a dynamic routing protocol, right? And we have also seen the static routing protocol, right? So these are some of the basics routing protocols. We have seen how to configure, how to check whether the connectivity in between all the internet networking devices, right? And we have also discussed some of the features of each and every routing protocols over there, right, in this particular thing. Okay, so we will stop here. Thank you for joining.